Hello and welcome back to part 2 of section 1.1 of geometry. Let's now complete the example problems together. I have copied the entirety of the example questions here on the sample examples page for convenience of the video, but you do not need to write the entire question when you are copying it down. I would say there are 4 main things you want to include whenever you are following along with the example. And that is, first and foremost, headings and numbers to keep yourself organized. Any given information that will be used in solving the problem. What you are trying to find, that is, whatever the question is ultimately asking for, make sure you write out exactly what that is. And then include any relevant diagrams that are given to you. So yes, you should copy down the diagrams, such as the one here in example 1, on your own page as well. After writing example 1, name lines and planes, and you could make note of you are trying to name the following: line with point W, plane with point X, and that would be sufficient. When copying the geometric diagram, go big picture first. So we have a plane, and I'm going to skew the plane in the other direction here just because it's easier for me being right-handed. Include that that is labeled plane P. We have a line going across at sort of a slanted angle there. That's line N. It has a point V, point W, point X, and over here is a point Y. And then coming up out of point X, a line at a bit of an angle. And there's a point here, point T, that is outside of the boundary of the plane. Since we're nearby, point Z here is on the plane, but not on any of these lines. And I'm going to take that point, that line from T to X, and we're going to extend it as a dashed line through the plane, and then continue as a solid line out the other side. And it looks like that whole line is labeled lowercase r. So a line containing point W is right here, so I can name anything on this line, or rather I can use any of the points along that line to name it. So we can call that line VW or WV, we can call it VX, we can call it WX, etc., etc. Or more shorthand, we can call it line N. Any of these would be possible names. B, a plane containing point X. Well, point X now is, I meant to use the highlighter there. Let's go highlight pink. Point X is right here. And the plane that point X is on would be the entire plane as part of our diagram, or the only plane in the diagram. So the easiest method would be to call that plane capital P, or we could also use any combination of 3 letters on the plane, such as VWX, or plane VWZ. Pick any 3 letters you see there that you like. Just do not use point T. Point T is not on the plane. That cannot be part of your name. And I would also specify here, let's not use VWX or any 3 points that are already collinear as well. We need 3 points that are not collinear to define the plane. So it looks like you will have to include Z because all the other ones are on the same line. So as long as you include Z and any of the other two that are not T, you'll be okay. On to example 2. Modeling points, lines, and planes. We are asked to name the geometric term modeled by the objects in the picture. So let's get a good look at the picture. It looks like a bulletin board. We've got some cards and some pictures pinned to the board, and there's a few objects over here that have been highlighted. There's some lines and points that have been labeled for us. Now, we could certainly identify points, lines, and planes from this board very easily. For example, we have a point here represented by the push pin. You could talk about the line that is the edge of this card, or maybe the plane that is the whole piece of paper. But we are specifically told to name the geometric terms. So we need to use these ones over here because there are letters that we can use to actually name them. So what the point that we have is we have point G represented by, there is a bit of a push pin. You can kind of see it there. So we can say the push pin represents point G. We can say the paper edge, the edge of the paper. By line, I need 2 points on the same edge, so we're going to use HJ right there. Remember, you can use the letters interchangeably and use the line symbol above them instead of writing out the word line. And we could talk about the entire plane of that whole sheet of paper, again, by using any three. So we can say plane HJF or plane GHJ. We'll say the paper sheet represents plane HJF. There we are. And example 3, draw geometric figures. So now we are going to draw our own diagram from scratch. Part A is a throwback to Algebra 1. We have lines AB and CD intersect at E for coordinates on A, B, C, and D are given on a coordinate plane. Point F is coplanar with these points, but not collinear with line AB or line CD. So let's start by drawing a coordinate plane. Whip up a quick set of axes here. Looks like 4 is the largest number in our coordinates, so we can make ticks up to 5. 1, 2, 3, 4, 5. That should be sufficient. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And since this is a quick sketch and we don't need any particular scaling, we can assume a scale of 1 unit per tick mark. We don't really need to label, but let's be thorough. Let's add just the outer labels there, the 5s and -5s. And this is our X, this is our Y. Keep the algebra teachers happy. So point A then will be at -2, 4. Over 1, 2, 1, 2, 3, 4. Right there is A. B is at 0, -2. So right here is B. Actually, I'm going to move that label to the other side so that I can have clear path for my line. I ran over the -5, that's okay. Point C is at -3, 0. Let's go a different color. 1, 2, 3, and 0, so C is right here. And D is at 1, 2, 3, 1, 2, 3, right there. That'll do for line CD, which means our intersection, they intersect at E, so that will be point E. We are not tasked with identifying the coordinates of point E, but it does appear to be at approximately -1, comma, approximately 1. That is just a graphical estimate, might not be exact. You can run the algebraic calculations to determine that with certainty. Point F then is coplanar with these points, so it's in the same plane. That's good, so we can leave our 2D representation, just put it anywhere on the page so long as it's not collinear with the other two lines. So don't put it on those lines or in the path of, so that would be no good. So let's just stick it anywhere where there's some open space down here. There's point F. Okay, and for part B, QR intersects plane T at point S. There is no symbol given unless I accidentally cut it off. So I'm just going to assume that's going to be line QR. Let's create a plane. You know what? Let's go really wild. Create a more vertical looking plane. Why not? Just do something different. And we have, so this is plane T at point S. So point S is somewhere on the plane, and we have a line QR going through it. And we could put Q and R anywhere on here. You could put them both here. We can call that QR. Or we could extend this line through the plane, and maybe instead we want to put point Q on the other side. Up to you. We have options. And finally, example number 4, interpreting drawings. We are looking at the provided figure and counting and identifying particular features here. So first, how many planes appear in this figure? Let's go with the obvious one. You got number 1, this big sheet of paper right here. And then there appears to be a, let's see, 1, 2, 3, 4, 5 pentagonal pyramid sitting on top of it. Each face of the pyramid is a triangle, but that is part of a separate plane extending out of the plane here, X. So I'm going to say that this is a total of 6. 6 planes. Next, name 3 points that are collinear. 3 points all on the same line. Looking around, I see this line here, but it only has 2 named points, so that won't do. The only 3 I see together appear to be right here along this edge of the pyramid, J, K, and D. So J, K, and D are collinear. Next, name the intersection of plane HDG with plane X. Plane X is the large sheet, the desktop, if you will, which our model pyramid is sitting on top of. And HDG, H to D to G and back to H, will fill in this triangle, this triangular face of the pyramid. I would call that the frontmost face there. And we're looking for which points are also on plane X, and that would be right here. H and G are also on plane X, so they form the intersection, or rather, all the points between H and G form the intersection. Remember, the intersection of 2 planes is always a full line, so the answer is truly line HG, or GH. And finally, at what point do line LM and line EF intersect? Explain. The fact that we have to explain the intersection of two lines is a bit of a hint. Let's take a look. Let me clean up my diagram a little bit. Line LM right here. Actually, let's use the highlighter again. And line EF, that would be this one here. Remember, it extends infinitely in both directions. So notice these lines could intersect somewhere around here. That point, however, is not named. It's close to point L, but it is not quite at point L. That is far enough away that we can't say, oh, maybe, it's just sloppy, maybe we could fudge it. No way. So there is no named point of intersection here. So we will have to specify that as our answer. What point do LM and EF intersect? An unnamed point on plane X, and we can say it is near point L. This concludes the example problems for section 1.1. So long, farewell. Enjoy the rest of your day.